you're comfortable starting.
Okay. Thank you. And I'll say this again, but a special thanks to the observers who have made all of this possible for the last 50, 60 years almost now. I was just talking with some folks in our department who were telling me about one of the original Lilacs stations going back decades. That's right here on Game Farm Road in Ithaca, New York. It's really through the effort of all of you who go out year after year and write down what you're seeing that makes the modeling and the predictions that we're trying to put together possible. So thank you. I'm going to start here where we left off. This was the slide, I think one of the last slides I showed during the webinar that we did on March 3rd. Made a prediction that we would see early spring in the west, late-ish with low confidence in the southeast based on the seasonal forecasts at the time, and average up in the northeast. So for Ithaca, New York, average is April 15th, and you know, my wife and I had a sort of a running joke going on about, you know, her bet for spring was earlier than mine. Mine was for April, which should have been April 15th. I actually bet at April 12th. Hers was for the end of March, and I've got some images of what it looked like in Ithaca, New York at the end of March. And also, I should say, for those of you who are in Ithaca today, I think there are a number of you, we define spring as the appearance of the first leaves on the lilac bushes. So that did happen a while ago. What's happening today, I realize, might feel like spring hasn't happened yet. But for our definitions of spring, we're using the appearance of the first leaves on the lilac bushes, which tends to happen in the middle of April in upstate New York and other mid-latitude regions. And then the second index we're using for the timing of spring is called the bloom index, and that's the appearance of the blossoms, the burst of those buds into blossoms on the lilac bushes as well. So rewind back to March 3rd. March 3rd was still very much winter time up in the Northeast and throughout much of the Midwest. Later in the same week that I gave the webinar, went up onto the roof of the building here on campus to take some pictures with my lab to get ready for the spring season. This is what it looked like, very typical. You can see there's some patches of snow still on the quad down there. No leaves on the trees. There's actually, if you look closely, there's ice on the lake. And this is the state of the system. This is the state of the land surface in early March, you know, pre-spring, before anything has really gotten very interesting, March 3rd. Also, I wanted to do a few little reminders, a little recap from some of the stuff that we talked about on that March 3rd webinar. The main one being that something really fundamental to the timing of spring is this idea that we've got year-to-year variability. So the timing of spring, the emergence of those first leaves on the lilac bushes isn't the same day from one year to the next year. Now that in and of itself wouldn't be that interesting, because you could explain it as just being random or stochastically driven, random plant responses to weather fluctuations. At the same time, there is this coherence, this structure of this interannual variability in the emergence of first leaf and other phenological indicators from year to year. And again, that by itself wouldn't necessarily be too interesting, because you could explain it as being just a function of the latitude or the length of the day, or some other deterministic parameter of the climate system. But when you put those together and you have interannual variations and large-scale coherence, that's the hallmark of something interesting happening on the climate side or on the atmospheric side that's pacing or modulating the timing of spring. Again, just in the spirit of doing a little recap here, this is a time series, just happens to be from one station for 1 year, historical station for 1 year, showing temperature, Tmin and Tmax through time. And one of the hallmarks of spring, the start of spring, is this appearance, this emergence of warm weather events. You know them when you see them. How do you know spring is sprung? You know it because the plants are coming out, people are going outside, taking off their clothes, it's warm, it just feels better. You really notice this in a place like Ithaca, New York, where I live now, how much warmer and nicer some of those days are as spring starts to make its approach in March, April. So I've marked those here as warm events. And these are the footprint of something happening in the atmosphere that drive those events. We're doing all of this in the context of a changing climate. And the monitoring that you're doing, the monitoring that NPN is overseeing, the modeling that we're doing is really, I would say, maybe not its infancy, but certainly still in its juvenile stage. But we're trying to get the instruments in place now to plan for and adapt to climate change, so that as we enter this warmer world of the 21st century, and whatever happens with our plans or strategies to adapt to climate change or to mitigate climate change by reducing greenhouse gas emissions, whatever happens, we're locked into a certain amount of climate change. And because of that, it's critical to try and use the indices that we have and develop new ones to track seasonality, to be able to plan for things like the start of the growing season, which also corresponds to the start of severe weather, which also corresponds maybe in the West to an earlier fire season. So this effort sits in the backdrop of climate change. And the way that I like to talk about climate change and explain climate change, especially when there's some potentially controversial audience, is usually just about the physics, the really basic part that we understand the best, which is something called radiative heat transfer. And anyone who's familiar with the idea that their hands would feel warm if you put them around a flame in a cold room like this can understand radiative heat transfer. But to show it a little bit better, to show what's really at the essence of what we talk about when we're talking about climate change, is this invisible light we can't see unless we have an infrared camera. So I wanted to share with you a little demo that we cooked up and put on YouTube with an infrared camera to really visualize the invisible light that's underpinning climate change before we get back into what it means in terms of spring onset and changes in spring in North America. So this is just a little, I think, about 2-minute video that I'll play. Maybe, if it doesn't freeze up.
So Toby, we can't hear anything with the video. Should we be hearing sound?
You should be hearing sounds.
Yeah, I don't. Maybe you could just kind of talk along. We can see it just fine.
Okay, so apparently you cannot hear what's being said, I'm told. Essentially, this demo is using the infrared camera here on the left and a blowtorch to heat up a metal earth. And when it's heated up along the equator, it glows in the infrared. And since you can't hear that, I will just fast forward here and talk you through what I'm actually hearing. So put an ice cap on top there for Greenland. And now you can see in the infrared the light radiating off the model planet. So the greenhouse effect gets its name from the fact that our atmosphere is transparent and invisible wavelengths. So light just comes right through. And it's reflected in the infrared. So our planet disappears, this model planet disappears in the infrared. Just like a greenhouse lets in invisible light, and the long-wave radiation has a harder time escaping. So it's analogous to putting on a sweatshirt. You put on a sweatshirt and it traps more of that radiation closer to your body, that heat closer to your body. We experience that slowdown, that slowing down of loss of heat as warming. Just like in the greenhouse effect in our atmosphere is to trap more of that outgoing long-wave radiation. And it slows down the loss, and we experience that slowdown as it's warming. All right, well, I'm sorry the audio didn't play for that, but the main point there is that just from the basic physics, we would expect to see warming because we have introduced an imbalance into the atmosphere. We've trapped more long-wave radiation in the atmosphere. We've slowed down the rate of heat loss of the planet. Just like putting on a sweatshirt slows down heat loss. We've slowed down the heat loss of the planet, and we would expect to have that imbalance play out in terms of temperature. And when you look at the global temperature averages, it sure does. You see this long-term trend. Now, this is global temperature. And what we care about, most of us who live on the ground, live in some part of the country or the world, don't care about the global average that much, or we're concerned about it in an abstract sense. It doesn't play out very strongly in ways that seem directly relevant. What matters is the year-to-year, day-to-day, month-to-month variations of weather and climate. And so now, let's get into 2015. Let's look at 2015. And this is another animation that's just going to show minimum temperatures in 2015, starting in January and ending, I think, yesterday. You can see it starts off very cold, below 10 degrees Fahrenheit. And you can see there are these pulses of cool air, cooler days driven by large-scale circulation patterns in the atmosphere. February was one of the coldest Februaries in Ithaca. I think the second coldest only to 1979. March, still very cool. And then we start to see some warming in April. These are minimum temperatures. Again, there's this pulsating, this imprint of large-scale weather processes on the ground that we feel. May, end of May, yeah, just a couple days ago. All right, so the first, we don't actually have a nice phenological indicator, a model that we have yet for the first, what I would call, window of spring onset. But I'm going to refer to this provisionally for now as the road bike index. A road bike index for me is the day of the year when my own phenological activity is to start riding my road bike, which is this picture of it right here. And for me, this year, that was March 13th, so about a week and a half after I gave the last webinar. It was warm enough for long enough that there wasn't any more snow on the streets for the most part. And the likelihood of snow was small enough that I felt comfortable starting to ride my road bike once again. And now at the same time, if you look at what's happening on the ground, of course, the crocuses and the other really early plants that pop out of the mud were responding to that early window. So the road bike index is probably the sort of I guess the time of year I would call pre-spring. Middle of March up here, probably February, end of February in other parts of the country. And I want to fast forward to what that looks like over here in terms of minimum temperature. There we go. You can see from about the middle of March onward, those very cold nights, the very cold lows become less frequent. And at the same time, the amount of snow that we got, this is a nice way of explaining it. This is an analogy for a friend of mine that I have to credit him for. So the difference between winter and spring in Ithaca is that in winter when it snows, you have to shovel your driveway, because if you don't, it'll stick around forever for the rest of the winter. In spring, it still snows, but when it snows, it's likely enough that it'll warm up that you don't have to shovel the driveway. So I guess another sort of early spring index would be the driveway shoveling index. So that's the first one. And we don't have a good plant-based phenological indicator yet for that window. The next window in spring, which is the one that people really notice and the one that gets the most attention, is what we're calling the leaf index. And this is the window when people are going out and it's warm. It's this first sort of long, prolonged pulse that tends to happen in the middle part of April or early April. Some places it happens in March, and of course in some places it happens even later. But up here in Ithaca, New York, it tends to happen in April. This animation is going to be the leaf index. So this is the model of the timing of the bud break, the burst of those leaf buds on the lilac bushes and the other 2 species of honeysuckle that are going into this model as an average. Think of it as when the shrubs in your yard start to open up their leaves. The animation is going to start all the way at the beginning of the year, and the color corresponds to the time of the year. Everything after the day on which this animation is occurring is masked down. You can see this green wave start to propagate through March. The bike index passed sometime back there. April. And finally, by the end of May, most of the country, with just the exception of maybe the highest elevation Rockies, is in spring. Here, we now have another index, another spring indicator, the third window, which is when the leaves put on, or the lilacs put on their blooms. The buds that hold the blooms burst open. You get that brilliant purple color, indicative of really the glorious part of spring. Or if you have allergies, probably the worst part of spring. So there it is. A little bit later. It tends to happen 2 to 3 weeks after the leaf index on average. And it varies. It's not perfectly correlated with the leaf index. There it is. It stops on May 17th. Now, one of the interesting things that happened this year is we had this, this running bet between my wife and I. She predicted the end of March, and I had said, well, I think probably it'll be more like April. And at the end of March, it was still snowing. The lilacs in our yard actually put on their leaves. I'd said April 12th. The lilacs in our yard put on their leaves on April 18th. The average for Ithaca is April 15th. So if I'd actually predicted the average, I would have been a little bit closer to being right. But I think being within the 6-day marker is not so bad. It's kind of exciting as spring was unfolding this year. One of the things that we did is the National Phenology Network's webpage, they have data that is collated by you guys, by you, the observers out in the field, and they were kind enough to download it and share it back with me so that I could make this map midway through spring. It's actually showing you in colors the day of the years that you, the observers, were reporting versus my model. And in some cases, the correspondence is pretty good. The colored dots are about the same as the underlying model. And then in other places, we're way off. And we're not really sure why that is. It probably has something to do with topography, except down here, it might have to do with moisture more than topography. One of the things we've noticed about lilacs is that they seem to put on their leaves later when it's dry, so that there's this warm pulse, but if it's a dry warm pulse after a dry winter, they maybe hold on for a bit longer before putting out the leaves. We're not sure about the details of this. There's also some other, I would say, pretty spectacular misses embedded in this, and we're looking into why that might be. Right at the end of March, I got this nice email. It should say March 31st, not May 31st. This is from Mark Schwartz, who's a pioneer of this effort, really the first to develop the models that we're using still today. I'll let you read it. This happened a little bit earlier in the Midwest, and we saw it. This is what it looked like in Ithaca, New York, on a weekend of Easter. So still not very much like spring, beginning of April in Ithaca, New York. I can't tell you how many times we said that around my house this spring. April was definitely, the first part of it anyway, was not very spring-like. But then, got this nice email from a star undergrad in our department on March 30th, a little bit of hope, a little bright spot. He'd been watching the long-term 10-day forecasts and sent me this map prediction about the start of spring, right at the beginning of April, looking down just right at the end of March, beginning of April, looking down almost 2 weeks out at the possible breakdown of the jet stream and a transition to a warmer pattern, warmer weather sometime around April 10th. And sure enough, April 12th is when we really started to see the warmth. That was my prediction. So the leaves didn't come out, but at least it was warm on the day that I predicted. That whole week, April 12th to 18th, was just beautiful. This is a typical site from the week of April 12th through April 18th. Now, what's going on? What's happening in the atmosphere? What are these weather patterns whose footprint we see on the ground sometime in April? Conceptually, I just want to show you this before I show the next animation. You can think of there being cold air masses in higher latitudes higher up towards the poles, and warmer air masses further south. And these are just drawn schematically here. And then between those, you've got the jet stream. So the coloring here on the map is wind speed at the upper level of the atmosphere, 250 millibar height. So upper levels of the atmosphere, very strong winds. It's close to 70 meters per second. This is coming out over the Pacific, and then the jet starts to wiggle as it makes its way across the North American continent and continues along out into the Atlantic. This is middle of February, so still very much a wintertime pattern. And you can see this move along a little bit. And if something really unusual happens during February or March, you might get some of this warm air further north than you would normally expect it. But for the most part, the jet stream is almost like a door, or it's indicative of this separation between the warm air further south and the cold air masses further north. And when that door is shut in most of winter, we simply just don't get those warm, balmy days that trigger phenological events that signal to humans and other species that spring has arrived. So this next event, I'm actually going to show you the interval that spans the time when we experience spring, both the bike index as well as the leaf index in Ithaca. So it's going to start in February, and it's going to run all the way through the end of April. And what I want you to look for is, first of all, in the earlier part of the animation, this very robust, very well-defined, wavy, strong jet stream. By the time we get into April, end of March, it's going to weaken, and then it's going to split, and we're going to see a subtropical jet that comes right across here by the time we get into April, and a polar jet that's much weaker, much more calm than what we see in the beginning. So let's watch that. This is when Boston is just getting hammered by snowstorm after snowstorm. March. Should say this is 6-hourly data, so you can really see the ripples, the movements, the waves in the jet stream as it makes its way over North America. And when when we have air on this side of it, it's cooler. And this side tends to be warmer. There we are in April. See this emergence of a new jet feature. That week of April 12th through April 18th, just like Star undergrad predicted, jet breaks down, reorganizes, and we get this balmy, warm, lovely weather that made you finally want to be outside. So that's really interesting because, okay, at the end of that period, the lilacs came out. Also, a bunch of flying ants came out of the ground in our backyard. Probably at least half a dozen other shrubs put on their leaves. The daffodils, the tulips, basically all of the bulbs that we have in our garden were bursting. Birds were going crazy. Squirrels were going nuts. It was a very eventful week, very dramatic, not a subtle feature at all. Now, the exact date that you put on the timing of spring is probably a function of whatever species you're most interested in. But in general, that week from April 12th to April 18th is when it happened, when it started. Now, at the same time, in the upper levels of the atmosphere, far away from what's happening on the ground, there's this fundamental reorganization of the jet stream and the jet structure. And from a scientific perspective, that's just a very compelling problem to try to dig into. And that's exactly what we're working on. So this is ongoing research to try to understand what the connection is exactly between the large-scale structures in the atmosphere, the dynamics of the atmosphere, and the impacts on the ground and the cues for certain species to get to work in the spring. All right, now back to our predictions. This is what we were looking at before I did my webinar on March 3rd. This is the seasonal forecast issued by NOAA, 3-month outlook. And based on this and what was already happened, we had made this for our initial Springcast. So Springcast version 0.0, year 1 of Springcasting. Early in the west, average up here, and late-ish in the southeast. And here, in the next one, is what actually happened. So, what are we looking at? These are anomalous days. The units are days that are different from average. So a negative number would be earlier than average, red shading, red patches. And cooler colors would be later than average. And gray, this zone, plus or minus 5 or 10 days, that's just sort of average. So sure enough, it looks kind of sort of average in the northeast. The southeast was earlier than average. So we kind of blew it there. And the west was early, as expected. That result was partially built in because by March, the west was already undergoing that transition into spring. That's for the leaf index. And the picture is pretty similar for the bloom index. And this is from yesterday, so some high elevation sites have still not seen the bloom index yet, and higher latitude as well. So I'll let you judge for yourself, and I'd love feedback on how you think we did. This is the NOAA seasonal outlook. This was the ECRL, our forecast for spring onset, based partly on NOAA and partly what was happening on the ground already. And this is the leaf and the bloom. I mean, I could say we, 2 out of 3, maybe, not so bad. It's a work in progress. Next year, I hope you'll tune in again. We'll do this again. We'll be more quantitative, and we'll have more statistically robust results, hopefully. At least we'll have better statistical quantification of the uncertainty and the skill of these kinds of forecasts. That's what we're working towards this summer right now, actually. Just wanted to show the global picture again to tie this back to global climate change. A lot of people complained about the weather and the winter that we had in the Northeast. A lot of people asked me, what's happening with climate change? Dropping off our daughter at school. Where's that global warming now, Toby? Well, the answer is everywhere. There's still very much a strong climate change signal outside of this little weird pocket that we've been living in the Northeast. If you look back to March, you see this even more strongly. The Northeast was just anomalously cold. It was a cold spring, cold winter in the Northeast, but the rest of the globe is really cooking, especially the Northern Hemisphere. And at the same time, I think this map and the results that we've been looking at drive home something that's critical for understanding and being able to explain and talk about what we're talking about when we talk about climate change, which is that the global long-term average, which varies a little bit from year to year, but is generally just sort of going up with maybe some slowdowns, but on the rise, is different from what we see on the ground, especially what we see in the springtime. And what makes spring unique, what makes spring really different, really unusual, and really special, is that you have this separation of the warm air to the south and the cold air to the north. And because of that separation, you can get some really crazy, weird things that you just can't get in other parts of the year. Because you can get cold outbreaks from the northern regions. You can get polar vortex types of things. It's just a misnomer, but we'll not get into that. You get these cold air outbreaks from the northern parts of the region. And it can slow down spring, and it can make spring feel especially anomalous and cool and weird in the Northeast and other parts of North America. And then you move into summer, and everything's sort of warmer, and that just doesn't happen. It doesn't happen once the atmosphere is restructured after some certain date as frequently as it does before that date. And so for climate change, understanding phenology and understanding how phenology is a proxy for the integrated effects of weather and climate is critical, I think, to our ability to characterize what we're seeing, talk about what we're seeing, and predict what we can expect on seasonal and even interannual time horizons. I talked about this work a lot with some of the stakeholders that we're involved with at Cornell. I'm on the land grant side of Cornell, so we work very closely with farmers and growers in the area and explain to them that National Phenology Network has this group of volunteers that use their iPhones in some cases or submit electronically observations of phenology of lilac, honeysuckle, and many other species. And universally, they thought this was just such a compelling way to try to adapt to climate change, just into the future, because if we could know something about the state of the system, both with the climate modeling perspective as well as the observational perspective, we might be able to make better decisions and make better uses of resources that are needed to adapt to and plan for climate change. So again, thank you, the observers, for making this possible and being a really pivotal part of this whole operation. All right, just to recap. This is what it looked like in Ithaca. Road bike index, so we need something here for ground cover. Next year, maybe we'll call it the crocus index or the snowmelt index. But for now, the road bike index was March 13th. Leaf index up here is April 18th. Bloom was May 3rd, and then last freeze was actually really late. And this is another thing that farmers and growers think about and worry about a lot, which is when do you get that last freeze event? Because if it's a long time after the first leaf, that's worse. 2012 is an obvious example where the spring was very early, but the last freeze event was average, sometime in April, and it cost, well, in Michigan alone, $500 million worth of damage. And this part of the story is actually much harder to try and predict because it's more random. It's more driven by just one event, whereas the leaf index and the bloom index is driven by this aggregation of events. It's a cumulative sum of events or average of events, whereas the last freeze is just, all it takes is one cold outburst, and it can do really horrendous damage to crops. All right, and then just looking ahead, some things that we're cooking up now, trying to develop more indices to have a more rich descriptions of the transition from winter into spring. We're looking to do quantitative forecasts with this national North American multi-model ensemble, which is a data product that's just recently become available, end of March actually, it was fully published. It has 30 years of data, daily data from I think 10 different modeling centers around the world, and it has about 100 members per ensemble, per modeling center, and they're issued every month. So it's a really just gigantic data volume to start working with, but it will let us do some really robust statistics. And we're going to, of course, try looking at something that I noticed very saliently this year, which is that once you're getting into this shorter time horizon, 10 days, 7 days, even if we can't get the details of maybe minimum or maximum temperature precipitation right, there is this more coherent story that starts to emerge, like our STAR undergrad predicted, which is that we might be able to say something qualitative that can be translated into a robust predictor of something like spring onset as we get into the maybe within 2 weeks of the events of interest. So we're looking at that. We also need to factor in moisture. One of the things that we heard from stakeholders while we were doing this is, well, that's all well and good, but an early spring, if I'm growing corn, an early spring is useless if it's a wet spring, and we don't factor that in at all. So we don't make any distinction between a warm, wet spring and a warm, dry spring. So we need to have that included in there. And of course, we need to look at other seasons. And just to give you a real sneak preview, I guess, at some of the challenges of looking at other seasons. Here's some of the current state-of-the-art models from this North American multi-model ensemble, looking just at precipitation from each of the different models. And these can be thought of is like different estimates of driving times using different map services. So if you want to drive from Ithaca to Washington, D.C., and you used Yahoo Maps versus Google Maps versus something else, you might get different estimates. While different models will give you different estimates of weather and climate variables. And when you apply a mask, in other words, you only colorize the regions from each model where there's a statistically significant signal. Picture looks even. This is looking at this just next month. This is looking at this month basically. There's much less potentially predictable, potentially useful information for the coming season. And I'm showing this to highlight some of the challenges with other seasons beyond spring. Summer in particular is very hard, and very hard to do precipitation. But if we look at temperature, the picture is a little better. Again, the places where there's no skill are masked out, and only the skillful predictions are shown. Blue is cooler than average, red is warmer than average. This is looking out into the summer, just 1 month ahead into the summer. And I'm sure most of you have probably heard that there's an El Nino underway. There was an El Nino underway last year, but it was kind of a dud. Now it's maybe looking like it'll be a real event that has much more of an impact on the atmosphere and on weather and climate downstream, and that means us. So, based on that, just really for fun, with very low confidence, here are your spring onset predictions for 2016. Based on the canonical relationships between El Nino and North American climate, we would expect most of the higher latitudes to be early and potentially see later spring in the southwest and southeast. But of course, that's nearly a year from now, and a lot can happen before then. So I hope that you'll stay tuned and especially check in next year and keep doing what you're doing, because it really does make a huge difference in what we're able to achieve scientifically with the contribution from this network of volunteers. So thank you.
Just in time, your phone's ringing. Thank you, Toby. That was really, really fascinating. We would be happy to take questions now if anybody has any. We've got definitely a few minutes that we could answer them. And it's really exciting too to see how things bore out. What would be really neat is when we are able to take all of the observations that were submitted for leaf out and flowering too, the start of flowering from this year for the lilacs, both the cloned and the common lilacs, and then compare those to the full maps that Toby showed earlier in the presentation of those spring indices, the bloom index and the spring index, and really drill down into where did we do a good job, where did the model really accurately predict the timing for that event, and when was that corroborated by an observer's report, and in which parts of the country were they not very temporally correlated, and then for those areas we're really able to kind of evaluate, well, is that because the model isn't necessarily performing well in that part of the country due to topography or other factors, or could it be because there was a big window of time from when the observer got the message and actually went out and collected data and reported it, or what might account for those inconsistencies. So we're definitely looking forward to doing that sort of evaluation and sharing it back with participants in Nature's Notebook as well.
Yeah, one of the things that we noticed was, in general, our model was biased late, so that we were getting reports of things happening a little before we were seeing them on the map. And that might reflect a bias in the model itself being cold, the underlying reanalysis data going in being biased cold in some cases. It might also be a feature, I guess, of the way that we're doing things, where we're using the average of two species of honeysuckle and lilac, whereas the observations are mostly lilac, and so lilac tends to be a little earlier than the honeysuckle, and it could be that we're biased late just because we're averaging in these other two indicators. So one of the things that we definitely need to do is pull things apart, maybe by species, to have that as auxiliary information for our interpretation of these transitions.
Definitely. And that actually is a wonderful segue into a comment that just came from Elizabeth Beaubien, who is an observer and the lead for a similar program to ours up in Alberta, Canada. She's, for years, decades maybe, has been coordinating observers in tracking phenology of many plants up in that part of the world. And she suggests for an early spring index that first pollen shed from maple, Boxelder, Acer negundo, would be a great indicator of the start of spring, at least for that part of the world. She says it's very easy to observe, and I agree, and it is all over the place, as she points out. I know, I remember being up in Michigan, and I definitely see it down here in Arizona. And yeah, Elizabeth, you're right. We have that on our list of species that we encourage folks to observe for our Green Wave campaign as well. We have a series of maples, oaks, and poplars that we've been encouraging observations to come in on because we're hoping to expand what Toby's been presenting on with the spring casting that's been focused mainly on the lilacs and honeysuckles to these other species that really are the ones that comprise a lot of the overstory tree canopies across the nation. And so you're absolutely right. We're in complete agreement that acers, that maples are at the top of that list, right up there with oaks and poplars too. So
yeah, I think that, I mean, there's several other things that I was asked about during the course of this, and they all do seem to correlate at, just qualitatively at that early window, that early March, mid-March window, the road-like window, and that includes the sap for maple syrup, a lot of the flat bulb flowers, and then the other potential application that we could envision by doing a better job of modeling that first window is the end of heavy salt use on roads in the Northeast, because that's also about the time that a lot of municipalities were running out of salt, and they would very much have liked to know how much could possibly be left in the system.
Yeah, it is definitely worthwhile to think beyond, those of us that are interested in nature, and why it's valuable to know why it's valuable to be able to predict when these things might actually happen. And there are so many very clear applications for it. Things like when we might expect the peaks in the allergy seasons to better help drugstores stock things like Claritin, to leaf peeping and other kinds of, tourism, thank you, situations where that can help municipalities that care about influxes of traffic or cities that have events. Like I know Holland, Michigan has a Tulip Time Festival, and that's a fixed point in time every year, but there is not the greatest likelihood that the tulips that they plant all across the town will actually be in flower when all of the visitors will be flocking in from different parts of the world. And so it may be useful for them to better expect when tulips might be in flower from year to year, to better guide planning that event if they could have it where it wasn't in the exact same week every year. Other things like wildfire seasons are tied to the phenology, especially in the spring, and other events like stream flow and snow melt that, again, like Toby has mentioned, are correlated, and a lot seem to be triggered by the same fundamental processes. Well, we aren't having a whole lot of other questions come in, but we really appreciate your time, Toby, and the presentation. One thing that I wanted to ask you for was, would it be possible for you to share with me the URL for the video that we didn't have the sound for?
Yeah, of course. Yeah, it's on YouTube.
That looks like a lot of fun, and I think viewers of all ages could really appreciate that. So once I get that, you can just send that to me,
sure.
And then we can distribute that to everybody who has signed up for the webinar today. And would you mind if we posted the link when we put the link to the recording to the webinar?
It's on YouTube, so it's, you know.
It's publicly available.
Exactly.
Cool. Well, we had a listener who said, "Thank you, Toby. This was fascinating." Thank you all for joining us today.
Thank you for joining us and for helping.
And do stay tuned we have a couple of other webinars coming up soon. In 2 weeks, we'll have one where we will be highlighting the myriad ways in which Nature's Notebook observations are being used in different sectors. And then our new visualization tool, which hasn't yet been unveiled, but will be forthcoming very soon, we'll be doing a live demonstration of that in mid-July, July 14th. So check out our webinars page for those as well. Thank you again, and have a great day.
All right, thank you.